Welcome student to the next video and next problem of revision series. So this is the third problem of revision series and it will be containing the integer type problem, because in this JEE Mains 2020 we are going to have a five integers of each subject. So having a practice of integer problem is very important in this scenario, because the pattern of the JEE Mains 2020 is changed. So what is this problem? This problem is containing the basic problem of thermodynamics. Again we are going to do the thermodynamics problem, because this is the fourth most important topic of thermodynamics. You must watch the video till the end to solve this problem and get the right answer. Get the right answer from the right method. So what this problem states, that during an adiabatic process, the density of a gas is found to be proportional to cube of temperature. Okay, the degree of freedom of gas is n. Find the value of 7n. Okay, the most important thing is that you must read the question twice, minimum twice, to get the correct answer from the problem, because the answer is always hidden in the problem. The value is asked is 7n, it is not n. So try to solve this problem. Pause this video and try to solve this problem of thermodynamics. Very basic problem. It's not very hard problem. Difficulty level is medium. The maximum time to solve this problem is 3 minutes. So you should pause the video and try to solve this problem by yourself. And after you are able to solve this problem, continue to watch the video till the end so you can get the right answer of this problem. Okay, so pause the video and try to solve this problem. Let's start the solution part of the question. As you already tried the question by yourself, this is an integer type of question, and this is very easy question if you just want to try to solve it. But in the exam perspective, this question is a bit tricky, because we are not asking for directly for the n, we are asking for the 7n. When we are asking for the 7n, that you are inclined to write the answer of the n, because this is integer type of question, and integer there is no option is given, so you don't have any idea that you are maybe you're thinking in the right direction, but you have wrote something else, because that is not asked. Just as example, if the efficiency of the cycle is arg, and if you write 0.75, that is correct, but if you write 75, that is wrong. So both the things can be possible in the integer type of question. So just try to remember what is asked in the question. What you get from the question is that a total different thing. But what is asked 7n, 14n, 10n, 100, and what is asked n by 100. So what is asked in the question? The question is given that the process is adiabatic and density is directly proportional to cube of temperature, and degree of freedom of the gas is n. So we have to find the 7n. This is a very basic problem. If we compare this problem with the second problem was also about the periodic process, and this is also about the periodic process. Now we're going to get the value of n, and then we're going to decide what will be degree of freedom, because we already know the degree of freedom of di, mono, and triatomic. So it will be just like that. So we're going to solve this problem now. Now student, we are going to solve this problem from the given function, the given equation. The equation was given, the density of the gas is directly proportional to the cube of temperature. So that is our first equation. And what we write, how we write the density in the ideal gas equation, we have the ideal gas equation PV equal to nRT. This is the ideal gas equation we have. So the ideal gas equation PV equal to nRT, we can always write the V equal to M divided by the density of the gas. So if we replace the volume of the gas in this equation of ideal gas, if we replace this equation, we will get this equation: pressure equal to mole into universal gas constant upon the mass of the gas into rho into T. So the proportionality if we get from this equation will be the density of the gas is proportional to, directly proportional to pressure and inversely proportional to the temperature. So this is the relation we can get from this equation. So if we put the value of the second equation into first equation, we will get the relation this. Okay, after putting value of equation 2 in 1. Okay, after putting the value of equation 2 into 1, we will have the proportional pressure and temperature. That the pressure will be proportional to the T to power 4. So if pressure is directly proportional to T to power 4, if we take every variable to the left hand side to compare with the polytropic equation, so we can say that this is the adiabatic process. So the polytropic regular polytropic equation will be replaced with the adiabatic equation. So we can say that the pressure into temperature 2 to power -4 equal to constant. And if you're going to compare with the pressure and temperature, as we know that P into V to power gamma equal to constant, this is the basic equation of the adiabatic. If we replace V with T by P, then we can say then P to power 1 minus gamma upon gamma into T equal to constant. This will be the equation in the term of P and T. So we can easily convert that equation into this equation. So we can compare those two equations with each other, in which P to power 1 into T to power 1 gamma upon 1 minus gamma is given. So if we compare this equation, so we will get the gamma upon 1 minus gamma equal to -4. So if we simplify that equation, we will going to get the gamma value is equal to 4 by 3. And as we know, the gamma is always Cp by Cv, and Cv is equal to F by 2 into R, and Cp is equal to Cv plus R. So after putting those two values, we will get the F by 2 plus 1 upon F by 2, and if we multiply the denominator and denominator with 2, then we will get F plus 2 upon F equal to 4 by 3. After that, solving that problem, we will get F equal to 6. And which gas has a degree of freedom equal to 6? This is triatomic gas, 3 translation and 3 rotation. We don't consider the vibration at our level, because vibration energy is a bit a quantum topic to discuss. Quantum level, we have to discuss that problem. So the 3 plus 3 translation and 3 of rotation degree of freedom, we will get of that will be the example of a triatomic gas. Triatomic gas as the example of water. Triatomic gas which behave like a diatomic gas, that is CO2. You should remember, CO2 have degree of freedom of 5. It is triatomic gas, but it will have a degree of freedom of 5. So the F is 6, but we are not asked the F, that is N. We are not asked this value of F. Easily remember, you can commit this mistake very easily, because this question is very simple as compared to last question. Then we can say the value answer will be 6. 6 you can also fill. So we are at the value of 7n, so that value will be 42. So answer will be 42. 42 is our answer. Thank you to watch this problem. Like, share, subscribe this problem. And this problem is asked about the 7n integer type problem. You're going to face the 15 integer type of problem, so you should prepare for integer type of problem during a preparation. Okay, thank you very much.